two-way frequency tables today. Two-way frequency tables. And we are going to use percents and ratios and fractions and decimals, a whole bunch with these two-way frequency tables. So I want to do a little warm-up with percentages. So you might have already figured out the right answer. We will see. And if you figured it out in your own little way, that's perfectly fine. If you get to the right answer, I do not mind how you do it. People think about percents and fractions in a bunch of different ways, and there's not just one right way to get to the right answer, right? But I'm going to show you one way. I'm going to show you the way that I learned it and the way I've been teaching it and the way that makes the most sense for me, okay? But again, if you did it a different way, but you got to the right answer, that's cool too. So up at the top of your paper, I'm going to have you write a little key, okay? And we're going to translate English into math. You think they only do math and English all around the world? No.
What is that last?
You guys seen Mean Girls? Maybe? Math is the universal language. That's what she says. Of. Is, what, and of. These three words are going to show up in many, many percentage questions, percentage problems, okay? What did I tell you of always means? Yeah, multiplication. What do you think is would mean as a mathematical symbol?
Equal. Times.
So if I say Tian is a student, Tian, student are synonymous with each other. So how would I write when I have this quantity is the same as this quantity? What symbol do I put in the middle? Someone said it, equals. Is means equals. And what, or what percent, is going to be an unknown variable, x. I mean, you can use whatever variable you want to, but I didn't hear you say that. I'm sorry. It's not like you get points deducted because I didn't hear you. It's just my own fault. I can't hear everybody at the same time. So 320 is what percent of 710? We're going to translate this again from English into a mathematical equation. So the numbers stay the same. So 320, what is? Equals. What percent is what? Is x. And then of is times. And then the number stays the same. So 320 equals x times 710. In other words, what number multiplied by 710 would equal 320? Any ideas how we can figure out what x is? Subtract? Subtract what? 710? What is it? Yeah, division by what? Yeah, we both divide both sides by 710. Now we're going to talk a whole lot more about solving equations in our next chapter, but this is okay. This is all we really need to know for now. So yeah, I'm going to divide both sides by 710. So that means that x equals 320 over 710. Can someone tell me what that is as a decimal? The decimal. Yeah, 0.45. So what is that as a percent? Exactly, 45%. Cool. Let's do the next one. So what percent, that's x. I don't want to put it there, I want to put it over here. That turns into x. Of turns into times. 320, our numbers stay the same. Is equals 85. What do I do to solve for x? Division by what? What? Huh?
For 320. 320.
Yeah, it's 320. I got to get rid of that 320 next to the x, right? It's x times 320. The opposite of 320 is dividing by 320. So I divide both sides by 320. So x equals 85 divided by 320, which is what as a decimal? Yeah. No. What? 85 divided by 320. Huh? Yeah, 0.26. I would, like, 2 places past the decimal is usually a good bet. So 0.26. Like, don't round that to 30% because that's off, right? 20. And what is this as a percent? Yeah, 26%. Is that clear? So is equals what is x and of is times. That's the way I figured those out at least. Okay, now let's figure out what percentage of students in our class are wearing hats. 2%? So does that just mean it's 3%? Yeah, so how many people are, so remember, percent, we're looking at part compared to whole. What is the whole? What's the total? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22. Should we count me or no?
Yeah.
23. It's true, everybody is a student. 23. What's my, so that's my whole. What's my part? Is how many people are wearing hats? Just 3. So yeah, so 3 over 23 gives us what as a decimal? Got it, Daniel. 0.13. What does that turn into as a percent? 13%. Perfect. Close. Yeah, if you did it 3 out of 22. Yeah. So now, what fraction of students in our class are wearing hoodies? So the whole is still going to be 23, and now let's count it up. Whole bunch. If they have a hood, then it's considered a hoodie. I still think it's a hoodie. 1, 2, 3. Evelyn, you don't have a hood, do you? You do? Your hair's heading it. You don't? Okay, so that's 4, 5. Ayana, do you have a hood? No. You don't have a hood? 6, 7, 8, 9, 10, 11, 12. I got 13. 13? Cool, we agree. 13 out of 23, what is that? I know I said to just get a fraction, but yeah, 0.56 as a decimal, or 56%. Okay, just for the next couple of minutes, I want you to create your own ratio. So look around the room and see if you can think of something that you can like have this many people dressed up for pajama day, or these people have, I don't know, someone did like short hair, long hair, or what's the percentage of people wearing sneakers, or something like that. So think of a ratio that you can just kind of figure out by looking around the room. Just gonna take a minute or two to do this. Don't overthink it, but tell me what the ratio is. What? You fellas, oh. I mean, that's my thought is like, arguably anything could be pajamas, I guess. And then when you're done writing your ratio, start answering number 6 and 7. Number 6 and 7.
Get out of this class really early.
3:20. 3:20. Let's get it right on time.
Bro, did the same thing I did, man.
It's threes.
3,
Four.
1,
Five.
2,
There's five. Five. I'm on your glasses.
5.
1, G9.
There's five.
Oh,
One over there. 2, 3, 4, 5.
yeah. If you don't want to count it, you don't have to count it. It's up to you. You are the master of your data set. Yeah.
Did you like write down what we did with frequency table? Did you like figure out like the percentage of FEMA that lived? Like so here's the total. Is that part?
Yeah. So yeah.
Okay.
And we're gonna look on the back of another one, and we'll go into like more depth of like all the different ways you can compare numbers.
That's where I was like going across and then I did that make sense.
Yeah. There's no total.
I thought about it. I was like,
Yes. Tell me.
I didn't even know. Like we like literally put like how much you're doing.
Yeah. Okay. Yeah.
oh. I actually, there's like something called a broken tip. No, I want this.
Mhm.
No, I already know this.
All right. Let's talk about number 6. So this is a two-way frequency table. Sorry. Typically, two-way frequency tables will have labels on the side as well as on the top, right? So we've got male and female. We have lived and died. So the number of males that lived is 367. The number of males that died is 1,364, right? Huh? So if you're like reading this and you're like, what is going on? Maybe you could add something to number 7. What does this make you wonder? What does it make you think? That's the question I've been getting all day.
Why is it still survival?
Yeah, perfect. Write that down. You're also not the first person to say that. So, and then typically as well, these two-way frequency tables will also have a total row as well as a total column. And we'll talk more about that once we get to the back of the paper. But just from looking at this, what do you notice about the graph? A bunch of people died. Talking about people who lived and died. Ooh, it doesn't specify if it's humans. That's a good point. Yeah. So these are all things you can notice about the table. And then I also want you to tell me something that this makes you wonder about. Like, why did so many more men die? What is it about? If you look at the back of the paper, maybe it'll give you a hint as to what it's about. Yeah.
Hey,
Yeah.
that kind of makes sense.
Yeah, so don't like quote me on the accuracy of this because I pulled it from the internet and we all know how accurate the internet is or isn't at times, right? But yeah, this is supposedly from like Titanic stuff. So they like let they let women and children get on the lifeboats first. So obviously way more men died than women did, right? Yes, there were plenty that couldn't get on, especially like the lower class people, right? Lower class people, the people who had a ticket that said they were third class compared to the people who had a ticket that said they were first class. First class people had a higher survival rate than the lower class people, right? Have you guys all seen the movie?
Yes.
Yeah.
Oh my God.
3 hours. Yeah. So let's scooch on over to the back of the paper, please. And we're going to take a look at this. This is a little bit more in depth, but still we have labels along the side. So here we have first, second, and third class. And then we have labels across the top. We have survive or did not survive. And then we have a total column, which adds up these two numbers together, as well as the like row columns, which add up. I should have said that the other way. These are the row columns, and these would be the row totals and the column totals. That's it, right? These three numbers equal that number. Okay, but let's go through these, and as we go through these, so you're going to get a number answer, but then I also have a little vocab for you to write down too. So first thing says, how many first class passengers did not survive?
123.
Yeah, 123, right? This is something that is called joint frequency. Joint frequency. So that is looking at one particular cell total. So we only looked at this little box right here, right? And that's how we got that answer. That's called joint frequency. Next question asks, what's the total number of second class passengers? Excellent. 284, right? And this is what's called marginal frequency. And marginal frequency is something that looks at a column or a row total, right? We got that 500 by adding up 201, 118, and 181. That's a column total. So column or row total. That's marginal frequency. All right, number 3, we're looking at percentage of passengers that survived. So when I'm talking about a percent, I'm looking at part compared to whole. So what is the whole in this situation? Yeah.
1,317.
There you go, Kenai, thank you. 1,317. And then when we are talking about, so percentage of passengers that survived, what's our part?
500.
Yeah, 500. 500. So that's the total number of survivors, right? So let's convert this into a decimal first. What do we get?
0.37.
Yes, that's good enough. 0.37. Good. And how does, yes, that's exactly it. As a percent, that is 37, right? So this is an example of something called marginal relative frequency. Marginal relative frequency. Marginal relative frequency. So whenever you see the word relative, you can think about two things, two numbers being compared to each other. So relative as in like two numbers relating to one another, right? Marginal relative frequency. And this is relating a row or column total compared to the table total. Okay, row or column total compared to the table total. I'll scroll back down in just a sec. I'm just going to show you. This was my column total, 500, and I compared it to my table total, right? That's marginal relative frequency. Okay, number 4. What percent of passengers were third-class survivors? So again, I'm looking for a percent, and I'm looking for a part over the whole. What's my whole? Yeah, good. So it's still that table total, and then what's my part?
181.
Yeah, 181.
Oh, yeah.
Yeah, right, 181. Let me show you where we got those numbers first, and then we'll turn it into a percent. So I'm looking at the amount of third-class passenger survivors compared to all passengers, right? So this is another relative frequency, but this one is called joint relative frequency. Which is a cell total compared to the table total. Cell total compared to table total. And if I want to turn 181 over our 1,317 into a decimal, what do I get?
0.13.
Which turns into 13%. And then last but not least, what percent of first-class passengers survived? What's my part over the whole? Yeah. .201 over 324. What do I get as a decimal? Equals 0.62, which is, yes, 62%. Anyone want to guess what this is called? What's the last 2 words of it? Look at these vocab words. What's the last word going to? Frequency is the last word. Yes. Yes. I'd be really impressed if you came up with the first word. Conditional relative frequency. So that's looking at a cell total, right? That 201 was just in one cell, just the first class passenger survivors. So cell total compared to a row or column total. Right? I'll scroll back down just one sec. So cell total compared to the row total. That's my conditional relative frequency. All right? Any questions on that? No? Feel good? Okay. So you can go ahead and turn that in when you're done filling it out. I'm going to give you your next half. passes there, then yes. So take a paper, pass it down, please. Take a paper, pass it down. Thank you. So on this paper, this is the last thing we're doing today. On this paper, you've got name, a little space for name, a little space for eye color, and a little space for glasses. So what you're going to do, you're going to go around the room and you're going to talk to every single one of your classmates. And you're going to get everybody's names written down, what their eye color is, and whether or not they wear glasses. Contacts count as glasses. Okay? So you're going to have to go around and get this information from everybody. Yes, include yourself. Include yourself. Like if you need to wear glasses to see. Do you wear glasses? When you're sitting in the back of the room not wearing glasses? Can you see? Okay.
How about you?
Yeah.
Brown.
You don't know?
Brown. Okay, still. Sorry.
You have contacts?
Your eyes will have to. Our contacts are in the back. Blue.
Good job. Uzziah.
She does not. Blue contacts and go. John.
Have we got another 5 minutes? Yes. Once you have everybody in the room, you can turn it into the inbox. Good. 23, including me. Should be 23. There's 23, including me, yeah. You can start because we got a couple minutes. Cross country.
Yeah? Saw you guys running in the rain the other day. I don't know if I saw you, but yeah?